Hi, 7th grade. It's really lonely without you guys here. I miss you guys a lot. Hopefully you got yesterday's lesson about the parallelogram, the area, and the angles. Today what we're going to do is start the new structure of our class that I had talked to you guys about a couple weeks ago, where we're going to start doing all 30 problems just for a little bit. We'll start them in class. We'll basically do the really difficult ones, the ones that I feel are really difficult in class, and then you'll do the ones that I think you can do by yourself at home. So today's classwork 164, lesson 61, pages 437 to 439, and we're going to do questions 1 through 30. There might be at some point during this video that we run across a question and I go, oh, that's a really bad question, we're going to throw it out. So even more incentive to watch the video. All right, so here we go. I thought I was going to run down a few of these, and after reading the problems here, number 1 starts off with a unit conversion. You have to convert a gallon to a pint, and actually a half a gallon to a pint. So go back to gallon man that we've drawn in, but I think you're more than capable of doing that one all by yourself. Let's start with number 2. So I am on page 437 in your book, number 2. It says use a ratio box. We don't have to use a ratio box. You can just set up a ratio. You don't have to draw a box. So we've got number 2, and we've got muffin recipe calls for oatmeal to brown sugar. Okay? In a ratio of 2 to 1. If 3 cups of oatmeal are called for, so where I have oatmeal, I'm going to put a 3, and it asks me how many cups of brown sugar am I going to need. So we'll let that be x. What we're going to do is cross multiply. We've done this numerous times, and we have 2x is equal to 3 times 1, which is 3. Divide both sides by 2, and you get x is equal to 3 halves. Now, in terms of baking, that doesn't really make a lot of sense. I don't have a 3/2 cup. So let's go ahead and turn that into a mixed number. 2 goes into 3 one time with 1 left over. So 3 halves is the same as 1 1/2. So you would need 1 1/2 cups of brown sugar. Hope that makes sense. Let's look at number 3. At any time, if I'm going too fast, go ahead and pause the video or rewind. Because you're in control of how fast you do this. Let's go ahead, and I think I can get the board on the camera over here. Number 3. And I'm not going to do all of them. We're just going to do ones that I think could be a little bit more difficult. Number 3. Ricardo ran a 400-meter race 3 times. His fastest time was 54.3 seconds. His slowest time was 56.1. His average time is 55. What is his time of the 3rd race? That's one where we've done these, but not with decimals before. We've done most of these average problems with whole numbers. So let's go ahead and let's list out the information that we know. So his fastest, and it doesn't really matter whether it's his fastest or his slowest, it's just one of the 3 times. So one of his times is 54.3. Another time, which happens to be his slowest, is 56.1. We're looking, I guess, for somewhere in the middle between these. That's not fastest and not slowest. This is what we don't know. But what we do know is that the average of all of these, the average is 55.0. Okay? So let's think about it not with the decimals. What we're looking for is this plus this to equal, then divided by 3 to equal that. So let's go ahead and figure out what they all need to add up to. And how we're going to figure out what they all need to add up to is by adding 55.0, 55.0 to itself 3 times. So we've got 50, 50, 50, which is is 150, plus 15. So 150, this is our quick mental math of the day. 150 plus 15 is 165. 165.00. We're going to go ahead and divide that. And if we divide that by 3, we'll get back to an average of 55. So now what we're going to do is we know that this plus this has to add up to 165. So let's go ahead and add 54.3 and 56.1. Add them together. So we get, let's bring our decimal down here. We have 4. We have 10, carry the 1. We have what? 11. So now let's go ahead and subtract. All right. This is 0. Let's go ahead and borrow, carry, bring down my decimal. 6, 4, 5. So 54.6. Let's hope that's the answer. Yes, that's the answer. So he ran this middle one in 54.6 seconds. If you don't remember how to do that, why don't you stop the video right now and go back and watch it again. Remember, we had to find, this is the average. Okay, it's 55. I needed 3 of these to figure out what my total is. Then I subtract what I know to find out what I don't know. And the only reason this looks a little bit more difficult is because it had a decimal there. If it didn't have a decimal there, it wouldn't throw your brain for a loop at all. All right, I believe that you can do 4, 5, and 6 by yourself. I would like to review number 7. Okay, number 7 deals with scientific notation. All right, scientific notation. And turning something into scientific notation and then turning something into standard form, which would be decimal form. So I have number 7. Number 7, it says, this is A. Write 0.00105 in scientific notation. So what I'm going to do is move my decimal. Remember, this is the decimal mover one. 1, 2, 3. I put it right here. So my significant digits, remember the ones that I need to write, are 1.05 times 10. Now we think to ourselves, what kind of exponent do I need to write? All right, well I need to write it as a negative because I'm changing a decimal into scientific notation. So, and I moved it 1, 2, 3 times. So here's my scientific notation for number A. If you need a refresher on that, go ahead and look back in the lesson numbers that are listed next to number 7. All right, letter B. We have write 3.02 times 10 to the 5th in standard form. All right, well, not a problem. We're going to take 3.02, and this is positive, so I'm multiplying by 1 with 5 zeros, so it's the same as multiplying by 1 with 1, 2, 3, 4, 5 zeros by 100,000. So then think to yourself, something by 100,000, that's going to be a big number, not a decimal, right? So I'm going to move my decimal 5 places. 1, 2, 3, 4, 5. Add my zeros in. So 3.02 is 302,000. And that's my answer. All right, let's keep moving here. Let's use, okay, on number 8, you are going to have to use prime factorization. You can do that. You might need to go back and revisit your notes for 24 because I think your notes for 24 are different than what the book, lesson 24, are different from what the book gave you. Let's look at number 10. Number 10 and 11. I want to definitely make sure we know how to do that because that was kind of what we did yesterday. So let me redraw this rectangle here. quadrilateral is ECBF. ECBF, what type of quadrilateral is that? Hopefully you said parallelogram. So that's number 10A. Number 10B, what kind of quadrilateral is ECBA? All right, as though this is in here, ECBA. That's a trapezoid. Remember, a trapezoid has two sides that are parallel, but it doesn't necessarily say what's going on with these other two sides. So it just has two sides that are parallel. That's a trapezoid. All right, number 11. We've got to do a lot, and this is really the one that I want to talk with you about. Number 11 gives us side lengths. It says AB and ED equal 4. So let's look at the units. 4 meters. We'll bring our units back in at the end. BC and EF are 6. BD and AE are 8. So from here to here it's 8, and from here to here it's 8. So if I know that, then I know this has to be 2, because 6 plus this part has to equal this whole part of 8. So we've got 2. All right, what's the area of quadrilateral BCEF? All right, so we have, what's the area of this parallelogram in here? And remember yesterday we said the parallelogram is the base times the altitude times the height like this. This, remember, is the slant height. This, remember, is your height. Again, I wouldn't stand against the wall and measure myself this way. I would stand perpendicular. So we're looking for some perpendicular height. So here's my perpendicular height right here, which happens to be the same as this 4. So the area of BCEF is equal to 6 times 4, which equals 24 meters squared. So there's your answer. All right, what is the area of triangle ABF? All right, my area of a triangle is equal to my base times my height divided by 2. So my base is 2. 2 times 4 divided by 2, which is 8. Divided by 2, which is 4 meters squared. Make sense? Just our area formula for a triangle that needs to be committed to memory here. Lastly, what's the area of quadrilateral ECBA? All right. Well, we've got this right here. They want us to find the area of this trapezoid. What are we going to do? Let's just go ahead. We already know that the area here is 24. The area here is 4. So the area of this whole trapezoid should be 24 plus 24, which is 28 meters squared. Does that make sense? As though I expect you to say yes. All right, you can do number 12 by yourself. Number 13. All right, let's go ahead and do number 13 together. We want to, what are we making here? Guess we need to make a stem and whisker, box and whiskers plot. Okay, sounds good. All right, clear out a spot in your book. This might be big. All right, I need to get a juicy marker. Hang on one second. All right, so we've got this data set here. We've got, we don't need to make anything. Let's just look at what we have. 2, 5, 5, 6, 6, 6, 7, 7, 7, 4, 8, 8. 9, 9, and 10, 10, 10, 10. All right, so they've already put them in order for us here. Let's go ahead and look at what they're asking us to find. They're looking at us to find, to try to find the median, which remember, the median of something is the middle. Think of the median of the road. The median is the middle. So let's go ahead and count it. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So right here is the median of my data set. Okay? Then it says find the first quartile and the third quartile. So remember, my third quartile is halfway between my end and my median. And then my first quartile is halfway between my beginning and my median. So let's go ahead and do that. We count in, we've got in and in, and, well, sorry, let me start that over. We go 1 in, 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 1 in. So my first quartile is going to be in between 6 and 6, which just happens to be 6. And then we'll do the same thing here. We go in 1, in 1, in 1, in 1, in 1, in 1, in 1. So here is my third quartile at 9. All right, so then it asked me on letter D, are there any outliers? Now an outlier is anything that's far away from the other number. So anything far away. Let's start from the middle. All right, 7's pretty close, 9's pretty close to 8. All right, 10's close to 9, 6 is close to 7, 5 is close to 7. The only outlier that looks like we have here is number 2. We could call this an outlier. It's rather far away from my median in this direction. I will come back and do another video, but go ahead and start with this, and we are going to work through number 30. My major concern is your success on questions 20 through 30. So when you come back to school, we will definitely be talking about those arithmetic questions right there. 21 and 23, I'm not super concerned about those, but everything else in that section I'm very concerned with. So go ahead and get working. Again, here is your assignment, and I will hopefully be creating another video for you in a minute.